Section 8.4, area of a parallelogram. Now listen. Definitions again. So let's make sure we understand what we're talking about. Okay, let's get the vocabulary down so we're on the same page. Okay? A parallelogram is a quadrilateral, that means it has four sides, a quadrilateral, whose opposite sides are parallel. So this side is parallel to this side. Okay? I could have drawn that better, but I didn't. Okay? And this side is parallel to this side. There are two pairs of parallel sides. Now let me ask you this. You may remember this, you may not. But let me ask you. Do you remember the name of a figure that has only one pair of parallel sides? Do you happen to remember? You've seen them before, you've heard the word before, but you may not remember it. It's called a trapezoid. A trapezoid has one pair of parallel lines. For instance, this line and this line are parallel. But this line and this line are not. Okay? They would at some point if they continued, right? Okay? So if they have only one pair of parallel lines, it's called a trapezoid. But two pairs of parallel lines are called a parallelogram. Do you agree that a square is a parallelogram? Yes. It has two pairs of parallel sides. How about a rectangle? Yeah? Now let me ask you, it has two pairs of parallel sides, right? What's the formula for the area of a rectangle, Peyton?
Base times height.
Base times height. You know what? That's the same formula for any parallelogram. Base times height. Okay? This shows, it says the diagram at the right shows the base, that's this length, and the height, the distance between these two parallel sides, okay, of a parallelogram. To find the area, we just multiply the base times the height. Please make sure that's written in your notes. Please make sure that you know that you have written down what a parallelogram is, that it's a quadrilateral whose opposite sides are parallel. Please make sure that you have the formula for the area of a parallelogram written down. Okay? You can see we're dealing with a lot of measurements with shapes, like the distance around a circle, or the area inside of a parallelogram. We'll probably do an area inside of a circle. In fact, I definitely know we will. Okay? Now,
Wait, the area inside of a circle?
we will go over that, yes. Not today. Not today. Okay? Now, I thought I had written this a little clearer, but I didn't clearly. Example number 1. This number is 7 inches. Okay? 7 inches. In example 1, it says find the area of the parallelogram at the left. How do I find the area of that? McVie? Area is equal to base times height. Let me ask you something, McVie. Do I know what A stands for? I mean, no, do I know its value right now? I don't. Do I know the value of the base right now?
Yes,
13. We'll put this in at the end, and we have something definitely that we need to talk about. The way we write our units with area. Okay, so we know the value of the base. Do we know the value of the height, John?
7.
It's 7. Okay, so John, can you tell me what's the area of this parallelogram? You have a calculator and you're welcome to use it. 91. Thank you, sir. You're awesome. But 91 what? Cows?
Inches.
91, not inches. Not inches. Luke?
Square inches?
Inches
Oh, inches.
squared.
Oh.
Okay? Because remember, when we're talking about area, we're not talking about a length. That would just be inches, right, Greg? But we're talking about how many square inches. How many little squares that are an inch on each side fit inside this thing. Think about this for a second. What if I took this triangle right here and I cut it off? I just cut that part off of the parallelogram and then I taped it. Here, I'll put it like this. I taped it over here to the other side. Now, what kind of a figure does that make? What does that look like, right? It's a rectangle. And we know rectangles are base times height. Okay? So the area of this thing is still the same. All right? That's a nice job. Base times height. Thank you, John.